Hello and welcome to today's class. We're looking at how to produce the isometric projection you'll be seeing at the right hand side of the screen. So we want to reproduce out this figure. So very first thing to do is to draw your isometric axis. So I'll just come here, take my t-square this way. I'll draw a vertical line upward this way, and then I'll come this way and take my 30 degrees to the left and also to the right this way. So I have this dimension, as you can see. So my next task now is to get out the length, breadth and height of the figure. So my entire length of the figure is 66. As you can see, my arrow indicating the value. So come here, measure 66. Before then, okay, 66. So this one gives you 66 here. Alright, this is 6 here. Next task there is to get the width, that's 40. So this is 40 at this part here, right? So next task, the entire height of the figure is 30. So measure 30. This is 30. Alright, I have that dimension ready. So I'll take this part up. Then I'll take this part here up. Right, I'll join this to this. Now I'll join this to this way. I'll take this way, and I'll close it up. I'll close it up this way. So it is from this box that figure you are seeing is being got from. So this is the box here. So I'll start carving out those shapes outside. So very first task is that observe that here to this part is taken. I will take in this part. Right? This part is taken. Taking this part here too. Of course, this part is taken. I'm also taking this part. Right? My next task there is that observe that there's an height of 10. That's 1 centimeter. So from here to here is 1, and it's taken. I will take in mine. Of course, I will close it up, close this part up this way, close here up this way. Alright, so I'll close this part here to up to the other part this way, as you can see, and then I'll take this part, close it up to this. So almost looking alike with the figure we have. So next task is that I'll go inward with a 16. Okay, before then I can come here. There's a length of 50 here inward, so measure 50. From here to here is 50. I will take in it, it's ticking. I will take in it this way. 50 ticking. So I will take my set square to transfer point to the other part, such that I will also take in this end part here. I will take in this end part. Right, as you can see what I'm doing. So my next task is that if you observe closely, there's a thickness of 13 to the right and to the left. So measure 1.3. Here is 1.3. Sorry, 1.3 to this point. So it's taking. I'm taking this part to this. Now also close this part with this. Right. So next priority is to extend the point downwards. So before then, I will take this one inward. I will take this part inward this way, such that this point here is to hit that point I took downwards. This one this way, right? Also, I'll take this one too. I'll take this one downward this way, so that it will hit this line. So next priority now is that I'll take this with this. a faint line. I'll join them first, a faint line, and then I'll close it up. I'll close here up with a thick line. I'll close here too up with a thick line also, right? Such that I'll thicken this part here. I'll thicken this part and also this part here. So I have this, right? So I'll come here. I'll take this inward, right? As illustrated from the diagram. So take this inward. Next priority is that there's a kind of box at the center here. To get that box here, we're going to go outward with 12 measurements. So measure here 12, that's 1.2 to this point. The 1.2, I'll take it inward this way, such that I'll come here, I'll extend this to that line, I'll extend this to that line this way, and I'll close this part up. Alright, so almost done. So I'll come here and thicken this part. I'll come here and then I'll thicken this part too. So this is like what you are seeing at the right side of the screen. So this is how to construct this isometric projection that you are seeing. So if you found this class helpful, do well to like this video, share this video to your friends and classmates so they can learn too. See you guys in our next class.
I just launched a book called The Shortcut to Academic Success. In this book, I share a lot of experience on how I evaluated during my time in school. This method really helped me a lot. If you're interested in getting this book, simply chat me up through my WhatsApp number that is shown in the screen. Hi there and welcome to this class. Let's solve this particular problem in the study of physics. Let's look at a problem under resistor. So last class we dealt with a sample problem under resistor. This is the part 2 to the example. So let's look at how we can possibly evaluate this particular problem using the knowledge of resistor. If you are not familiar with resistor, if this is your first time, I'll drop the link to introduction to resistor in the description below in the video description, right? So go there and check the link there to take you directly to our previous classes where we dealt with resistor introduction, right? Let's look at how this is possible. It says considering the following circuits, complete the table. All right, I have this circuit here. So in this circuit here, I have three resistors, R1, R2, R3, where the R1 is 120 ohms, R2 is 180 ohms, and R3 is 270 ohms. That's case 1. Case 2 is that this circuit have a voltage of 15 voltage. Alright, I have this place. It says I'm has to complete this table. It means I need to find this is voltage column, voltage row, let's say, current row, and resistor row, as you can see, and I have the power row. So I'm looking for voltage, current, and power for each resistor. So it means I need to find V1, V2, and V3. I need to find I1, I2, and I3, perhaps R total and I total. I'm asked to find the power at section 1, power at 2, power at 3, and total power. What do you do in this case? Yes, I did. First things first, my first task is obviously to find my total resistor, right? Total resistor. And observe that this circuit here, It's simply a circuit with a resistor. And for a circuit with a resistor there, we expect two things, either in series or parallel. In this case here, this resistor R1, R2, R3, if you check this very well, and if you're familiar with our previous classes, this simply R1, R3, sorry, R1, R2, R3 obviously are arranged in parallel. If you are in our previous classes, you should know why this one is in parallel. So I'm saying this, please. Solution. So we said that both R1, R2, and R3 are in parallel. All right. So we know that R1, R2, R3 are